Hello students, today I will discuss basic logic gates. Okay, so we know that there are seven logic gates. One is number one is NOT gate. Number two, that is AND gate. Number three, that is OR gate. Number four, that is NOR gate. Number five, that is NAND gate. Number six, that is XOR gate. Number seven, that is XNOR gate. So these are seven logic gates. So this NOT gate, AND gate and OR gate, that is called basic logic gates. So these are basic logic gates. And these two, that is 4 and 5, these two gates are universal gates. Why it is called universal gates? So using these gates we can design other gates like NOT gate, AND gate, OR gate, XOR and XNOR also. That's why it is called universal gates. Okay, so these two gates are universal gates. And 6 and 7, these are special types of gates. The special types of gates are XOR gate and XNOR gate. So these two gates are special purpose gates. Okay. So first I will start with NOT gate. So NOT gate, the symbol of NOT gate, first NOT gate, and the symbol of NOT gate is like this. Okay. So NOT gate, that is complementary gate, and it has one input and one output. So one input, just when we apply that this input is A, in that time we are getting output A bar. That means it gives a complemented output. Okay. Now the truth table of NOT gate. So how many inputs are there? Single input. So possible combinations are 0 and 1. Okay. So these are inputs, that is A input, output is equal to A complement. Okay, so one input, so possible combinations are 0 and 1. So first is 0 and 1. So when we apply 0 over here, in that time output will be 1. That is, we are getting the complemented output. When we apply input is 1, in that time output will be complemented. That means when you apply 1 over here, in the time output will be 0. So output will be 0. So this one, the truth table of your NOT gate. Okay, the symbol of NOT gate like this. Clear? Now second gate, that is our AND gate. Okay. So AND gate. So what is the purpose of AND gate? So it gives the multiplication output or a multiplied output. Okay, so ANDing operations performed by this AND gate. Okay, that means if we apply A and B, two inputs, that gives the multiplied output. Okay, A and B, if two inputs are there, and the output will be y is equal to its A dot B. That means it gives the multiplied output. Okay. So here two inputs are there. Now first I am giving showing you the symbol of this AND gate. So these are the symbol of AND gate. If we apply two inputs like A and B, output will be Y A dot B. Okay. Now here inputs are two. Okay. So in case of two inputs, so possible combination we know that 2 to the power 2. So 2 to the power n. So here n is equal to, that is number of bits. So if two inputs, 2 bits are there, that means possible output is equal to 2 to the power 4. So 2 to the power 2 inputs, possible input combinations are 4. Clear? So first combinations 0 0. So 0 0, that gives a number, decimal number is 0. Okay, so 0 0, first possible combinations is 0 0, then 0 1, then 1 0, then 1 1. Okay. So these are the inputs. 4 input combinations are there, and output will be, when A input is 0, and B input is 0. So when both the inputs are 0, in that time output will be 0. That is 0 into 0, output will be 0. You know that in case of Boolean multiplication, when we apply two inputs, both are 0 0. So in case of Boolean multiplication, output will be 0. Okay. Now when 0 and 1, in that time output will be 0. When 1 and 0, two inputs are there, output also 0. So when both the inputs are 1 1, in that time output will be 1. Okay. Now from this truth table, just we find out the expression for this AND gate. Now see here both the inputs A and B, both are 1 1. Okay. So that's why output will be 1. Okay. So for these inputs, this one your Y is equal to AB. Okay. Now NAND gate. Sorry, OR gate. Third gate is OR gate. So OR gate is there. Okay. So what gives OR gate? So OR gate, that gives a sum of two inputs. Okay. So that gives the summative outputs. Okay. So in this, just we see the symbol of this OR gate. So two inputs are there, like this. There are two inputs, that is A and B, and output Y is equal to A plus B. Okay. So that gives, the OR gate gives the output, that is A plus B. Okay. Now for these two inputs, again when we apply two inputs, the possible input combinations are 4. That is, two inputs are there, A and B. Output will be Y is equal to A plus B. Okay. So for these two inputs, possible combinations are 0 0, 0 1, 1 0, and 1 1. Just we apply Boolean additions over here. So in case of Boolean addition, when you apply two inputs, that is 0 0, in that time output will be 0 plus 0, it is 0, and 0 plus 1, 1, 1 plus 0, it is 1, 1 plus 1, that is also a 1. Okay. So this is the truth table of your OR gate, and this is the symbol of your OR gate. Next I will discuss with special gates, that is, sorry, not special case, universal gates. First I will discuss with NOR gate and NAND gate. First I will discuss with NAND gate. So what is NAND gate? So NAND gate basically AND gate plus NOT gate. Okay, so AND gate plus NOT gate. Now we see the symbol of NAND gate. So this is the symbol of NAND gate. Okay, so A, B, two inputs are there, and the expression of this NAND gate, that is AB its complement. That means AB that gives the AND operation, and complements that gives the NOT operation. So AND plus NOT that gives the NAND output. Okay, so complements Y is equal to AB its complement. That is the symbol of your NAND gate. Okay, now again two inputs are there. So two inputs, that is A, B. So possible combinations also 4. That is A, B, two inputs are there. Y is equal to A, B complement, that is the output. So for these two inputs, possible combinations are 0, 0, 0, 1, 1, 0 and 1, 1. So output will be 0, 0. So when you apply 0, 0, in case of AND gate it is 0, but when you are using the NAND gate, so NAND gate output 0 its complement. That means we are getting over here 1. Okay. Now 0, 1. So we are applying 0 over here, 1 over here. So 0, 1, that is 0, and its complement that gives a 1. Again, A is 1 and B is 0. So 1 into 0, that gives a 0, and its complement that gives a 1. Next one, that is our 1, 1. When both inputs are 1, that is A is equal to 1, B is equal to 1. So 1, 1 in case of Boolean multiplication, that gives a 1, but its complement. So its complement, if we are applying 1 and its complement, then output will be 0. So this is the truth table of your NAND gate. Okay, and this is the symbol of your NAND gate. Here, now I will discuss with NOR gate. So again, NOR gate. So what is NOR gate? That is OR plus NOT. Okay. Now two inputs are there. A, B, two inputs are there. So first that gives the operation of your OR gate. Okay. OR gate that gives A plus B, and again we are applying one NOT gate. That means OR gate plus NOT gate that gives the NOR gate output, that is A plus B its complement. Y is equal to A plus B its complement. So this portion A plus B, that is your OR gate operation, and complements, that is your NOT gate operation. Okay. Now again we are applying two inputs, that is A and B. Possible combination also 4, and output will be A plus B complements. So possible inputs, that is 0, 0, 0, 1, 1, 0 and 1, 1. So output will be, see here, when both the inputs are 0, 0. So 0 plus 0 in case of Boolean algebra, we know that when we apply both inputs are 0 plus 0, that gives the output 0. But here we are applying one complements. So here it is 1. So 0, A is 0 and B is equal to 1. So 0 plus 1, it is 1, and its complement, that is 0. Okay. Next, A is equal to 1, B is equal to 0. So 1 plus 0, that gives a 1, and its complement, that gives a 0. Again, A is 1 and B is 1. In case of Boolean addition, it will be, output will be A plus B is equal to 1. But here it is 1 complements is there, so output will be 0. Okay. So this is the truth table of your NOR gate, and this is the symbol of your NOR gate. Okay. Now I will discuss with XOR gate. So this X OR gate and X NOT gate, these two gates are special purpose gates. Okay. XOR gate. First, I will show you the symbol, logic symbol. That is XOR gate symbol like this. So two inputs are there, A and B, and expression for this XOR gate, that is A bar B plus AB bar. Okay. So these two inputs, that is AB, and output will be Y is equal to A bar B plus AB bar. So another expression of this XOR gate, that is Y is equal to A XOR B. Okay. So again you see two possible combinations, that is A and B. So two possible combinations, that means possible two inputs are there. So possible input combinations will be 4. That is 0 0, 0 1, 1 0 and 1 1. Okay. Now you see for this 0 0. So in case of XOR gate, you know that when both the inputs are 0, at the time output will be 0. And when one input is 0, another input is 1, that means output will be 1. Again, one input is 1, another input is 0, output will be 1. And in this case, when both inputs are same, in that time output will be 0. Okay. Now see how these expressions are coming. See for this 1 and this 1. So this is input where A is equal to, for this output. Okay. So where Y is equal to 1. See this expression. Here A is equal to 0. That means we are applying A bar. So this one is A bar and here it is 1. So A bar B plus next one. Here see A is equal to 1 and B is equal to complement, that is 0. 0 bar here, that's why B bar. So from these two outputs we are getting this expression. Okay. So these are the two table of your XOR gate and this is the symbol of your XOR gate. Okay. So next one, that is our X NOR gate. X So X NOR gate, again X NOT gate is equal to what? That is XOR gate plus NOT gate. Okay. So see here, so this is the logical symbol of your X NOR gate. So and the output expression of this X NOR gate is equal to AB plus A bar B bar. Okay. Inputs are two. That is A and B. So possible combinations again. 2 to the power 2, that is 4. So 4 possible combinations, that is 0 0, 0 1, 1 0 and 1 1. Okay. Now we see that first we write this expression over here. So in case of NOR gate, okay. So in case of NOR gate, when both the inputs are 0 0, in that time output will be high. So output will be high. When both inputs are different, that is 0 and 1, in the time output will be 0. So again, here the inputs are different, so it is 0. And last one, when both the inputs are 1 1, it is 1. So when both the inputs are same, in the time output will be 1. When inputs are different, output will be 0. Again, when the inputs are 1 1, in the time output will be 1. Now see how these expressions are done. See here, in your first case. Okay. So A bar B bar. Now you see where it is 1. So here it is 1 and here also 1. Now see here, when both the inputs are 0 0. So in case of, we know that in case of Boolean algebra, so how to represent 0? That is complement. Okay. So here it is A is equal to 0. That means A bar, and here also B is equal to 0. So we are applying B bar over here. Okay. And see for this AB, see this last one. When both the inputs are 1 1, that means A is equal to 1. So it is A, and B is equal to 1, that is B. So we are write AB over here. So from these two outputs, when this outputs is 1, we are applying, we are getting this expression. Okay. So up to this, thank you everyone.